आवाज नहीं
Wait! Did you download? Stand. Professional Studies Academy is one of the Central India's largest educational hub in which it offers courses at all levels. At IPS Academy, it has been our endeavor to provide education to students that leads to multifaceted development of their innate talent.
The oldest and the best educational institution of Central India, huge campus, impeccable infrastructure and facilities, providing quality education to the students in diversified fields. Now, this was the dream of an IITian, which turned into a beautiful reality and became probably one of the most decorated names in the country. When the mind is without fear and the head is held high, very rightly said by Sri Rabindranath Tagore, taught and followed by our institution, I would say IPS Academy does not only impart knowledge in the form of this institution of education, but it also makes sure to broaden the horizons of thought and character of the students who belong to the IPS family. Indeed, very lucky to be a part and change students' lives.
Institute of Business Management and Research. The need of managers in organization is continuously increasing, as well as the expectations from managers are continuously changing. IBMR, IPS Academy is meant for those who want to shape their career in business management and excel in it, and offers MBA degree such as MBA Core, International Business, Business Economics, Tourism Management, Working Executive, PGDM, PhD in Management and Economics. This institute helps students to become proactive learners and positive catalysts to change. IBMR has been ranked in the band 51 to 75 by Ministry of Human Resource Development. Even this college has been consistently ranked in top 50 institute in India, being leading business magazine. IBMR provide various facilities like library, well-equipped classrooms, computer lab with free Wi-Fi, seminar hall, etc. School of Hotel Management. It was established with the aim of producing professionals through rigorous learning and training processes, and offers degree in Bachelor in Hotel Management, BBA in Hotel Management. Students are provided with class training inside the college campus, which is practiced in kitchens, restaurants, bar, reception counter, housekeeping guest rooms, computer lab with IDS training package. It provides all facilities of students at its best. School of Fine Arts. It has one aim: to develop and enhance the aesthetic and creative mind of the student, which offers degrees like Bachelors in Fine Arts and Masters in Fine Arts. We provide students with art studio, creative classroom, exhibition conducted by students and many more. School of Education. It offers courses in B.Ed. By gaining this degree, one will be understand the final aspects of teaching in addition to the knowledge that is required to understand. School of Architecture. It offers undergraduate courses in B.Arch affiliated to RGPV. The selection is done by Council of Architecture throughout India. The demand of architects is never ending.
Here in School of Architecture, all the faculty members, we all strive to impart knowledge with a difference. Today we have an intake of 120 students and about 600 students study in the institute. And we believe in producing architects eventually who will be sensitive towards the nature and who understand the needs of the society today.
Here, students get practical training, which gives opportunities to the students to interact with the practicing architect. This college ranks among top 5 in the country and stand number 1 in Central India. School of Computers. In recent year, there has been increasing demand of MCA graduate from all corners of India. multitasking is buzzword for all the segments of industry. That's why SOC aims to prepare the students for this noble purpose. Institute of Engineering and Science. IPS Academy was mainly known by this course, which provides BE, BTech in Civil Engineering, Computer Science and Engineering, Computer Engineering, Computer Science and Technology, Computer Science and Information Technology, Electronics and Communication Engineering, Electrical and Electronics Engineering, Fire Technology and Safety Engineering, Safety and Fire Engineering, Mechanical Engineering, Power Electronics, Industrial Safety Engineering, Structural Engineering, Construction Planning and Management, Chemical Engineering. To provide value-based broad engineering, technology and science, where education and students are urged to develop their professional skills. This institute is playing a key role in creating an ambience for the creation of noble ideas, knowledge, and graduates who will be leaders of tomorrow. Institute of Fashion Technology. Born with the objective of developing fashion and promoting Indian talents at national and international level by providing right education in the right setting and environment from the best professional names of the industry, education at IFT communicates leadership, a sense of passion, energy, teamwork, and inspiration to the teachers. Here we make expertise in fashion and textile industry. College of Law. Law education has become the need of modern times and provides many opportunities in the field of judiciaries and others, which offers degree in BA LLB, LLB Honours. It provides all facilities to students. School of Performing Arts. It has one aim to develop and enhance the aesthetic and creative mind of the student, which offers degree in dance, music and drama. Here you can be music director, composer, singer, dance choreographer, disc jockey, actor and many more. College of Pharmacy. The degree here works right at the heart of human healthcare, taking on roles relating to the design and development of new treatments, prescription and care management, and advising on the range of medical options available. So you can secure job in pharmacies, in medical insurance companies, in clinical research organizations, and pharmaceutical industries. Institute of Science and Laboratory Education. This college is one of the premier educational institutes in Central India, imparting education in the field of basic sciences, which offers degree in BSc and MSc both, and also certified courses in library automation and Bachelors of Library and Information Science. This college provides interventions range from primarily person-focused psychosocial processes to involvement in social policy, planning and development, which offers degree in MSW. This college of established with the motive of providing skilled professionals with specialization to serve the industry. College of Commerce. College of Commerce offers courses like BCom Honours, BCom in Taxation, Computer Application, Foreign Trade, BCom Plain and MCom. College of Commerce serves with modern and innovative teaching practices. Along with the use of technology, it has well-equipped computer lab and modern library. Students actively participated in sports events and cultural activities. This college provides placements in MNCs, banking.
possesses brightness and prosperity. In spiritual world, light means life. So we can also think of light as giving us new direction in life. With this noble thought, let us start this event by lighting the lamp in front of Ma Saraswati, the goddess of knowledge, music, art and wisdom. I welcome our honorable guests, respected principal ma'am, and all respected HODs for lighting lamp.
Thank you, ma'am. Thank you, sir. Flowers are our way to express gratitude and respect. Therefore, I request our principal ma'am, Dr. Premlata Gupta ma'am, to welcome our eminent speaker, Dr. Shilpi Mishra ma'am from IIT Indore. Thank you, ma'am. As we know, some of our guests are connected to us virtually also. So here, I take the opportunity to welcome today's special guest, Dr. Pradeep Sharma sir, Scientific Advisor in New York, eminent speaker, Dr. Helen P. Kavita ma'am from SRM IST Chennai, and young rising talent, Ms. Priya Chaudhary ma'am from Western University, Canada. The right information brings knowledge, and knowledge is power, and sharing it is empowerment. So here, I welcome Dr. Pratibha Sharma ma'am, convener of today's seminar, for introducing today's event and increasing our knowledge.
Thank you, Nisha. A very warm good afternoon to all dignitaries. Honorable guest, Dr. Pradeep Sharma sir, Scientific Advisor, New York. Respected Dr. Helen P. Kavita ma'am, Professor Head, SRM IST Chennai. Eminent Speaker, Dr. Shilpi ma'am from IIT Indore. Principal, Dr. Premlata Gupta ma'am. Head of Department, dear Ruchi Srivastava ma'am. All heads of the department, professors, young scientists, and my dear students. On behalf of Department of Chemistry and organizer GWB, I, Dr. Pratibha Sharma, delighted to offer a gracious welcome to all of you and feeling immense pride to stand here before you in inaugural ceremony of today's event. Department of Chemistry, Institute of Science and Research, IPS Academy, Indore, organizing international seminar on breaking barriers in science in collaboration with IUPAC, ACT, and My Green Lab, California. I feel proud to be part of this event and very happy to brief the event amongst us. International Union of Pure and Applied Chemistry, IUPAC, is a global recognized union of chemistry organizations. Global Women Breakfast is the flagship event of IUPAC to promote the achievement of women in science. The main objective of the event is to establish an active network between science organizations globally to overcome the barrier in scientific developments and empower next generation. I am glad to inform you that this year we have associated with My Green Lab, California. It's an organization to encourage green laboratory operation and building global culture of sustainability in science. I hope you all watched the video to understand their programs and initiatives. Have you watched that video of My Green Lab? Students? Okay. Being a Green Lab ambassador, I personally request you all to join My Green Lab and promote green practices in chemistry lab and biology lab too. It's a matter of great pleasure that more than 450 events will be organized in India and across the world together on today. ACT promotes this event in India. We have celebrated GWB from last 2 years and organized international webinar and international colloquium in year 2021 and 22 with women scientists, prominent leaders and social workers. We have Dr. Padma Shri, Dr. Janak Palta, Padma Shri, Dr. Leela Joshi, Dr. Archana Chitnis ma'am, Cabinet Minister MP Higher Education, Dr. Sonia Alexander, Dr. Michelle Brown from Ireland were graced our previous events. They all share their research and interesting journey of women empowerment with us. Here are some glimpses and media coverages of previous events. I am honored to inform you that this year we have national and international personalities with us. I hope you all gain knowledge about recent research trends and enlighten your minds with honorable guests. Thank you so much. Namaskar.
Thank you so much, ma'am, for your informative words. A dream does not become reality through magic. It takes sweat, determination, and hard work. This defines the personality of our HOD ma'am. Now, I request Dr. Ruchi Srivastava ma'am, Head of Department of Chemistry, to kindly come here and say a few words.
Very good afternoon to all. respected principal ma'am, our speaker and guest for today, Dr. Shilpi ma'am, our speaker joined online, Dr. Helen Kavita ma'am. Good afternoon, ma'am. And heads of all department, Dr. Pradeep Joshi sir, Dr. Jitin Tripathi sir, and Dr. Dipali Shukla ma'am, faculty of all departments and students, and the participants who has joined online. A very good afternoon. On behalf of Department of Chemistry, I heartily welcome all in this Global Women Breakfast, the international seminar. Scientists have become the bearer of torch of discovery in a quest for knowledge. And I'm sure that we all are reaching out to new dimensions of research by breaking barrier in sciences. That is the theme of this Global Women Breakfast 2023, which is our flagship event of International Year of Basic Sciences for Sustainable Development. It will be a fortunate moment to refresh all the scientific informations and facets in this event. I hope we all inculcate that in our academics and research. Department of Chemistry is one of the leading department in sciences. We are running 2 PG courses and UG courses also. In the quest with academic excellence, we had made a great stride by capturing 40 plus merit positions, 5 gold medals, record and remarkable placements in our department. I feel privileged to announce that Department of Chemistry is recognized as a research center by DAVV Indore. We have 5 research guides in our department, and we have published more than 40 research papers in last 5 years, have 1 research project that is government funded, and many more accolades in research field. Our students are also have reflection of research in their profile. About 70 to 18 students has presented research papers in international and national conferences in last 2 years. They also carried out research projects other than the internship, which is a part of curriculum from our department. They all utilize the resources that are available in our department, like e-resources, like the instrument facilities. We have HPLC, we have polarograph, polarimeter, flame photometer, and etc. to carry out their projects. And we have also collaborated with other institutions for like student exchange programs and also some research work. So again, I congratulate to the event coordinator, Dr. Pratibha Sharma ma'am, to organizing this event. Actually, we all are organizing, but she is the coordinator of the event. So I must congratulate you. And also thanks to all the speakers and guests who has joined our program. Thank you so much once again.
Thank you so much, ma'am, for your influential words. Education is the passport to the future. Tomorrow belongs to those who prepare for it today. Education is the most powerful weapon we can use to change the world. Now, the person who has consumed herself to change the society and light the darkness in the life of so many students, the principal of our institution, Dr. Premlata Gupta ma'am. I request Principal ma'am to come here and address the gathering.
A very good afternoon to all, and I extend my warm welcome to Dr. Shilpi Mishra, Dr. Helen from Chennai, Dr. Pradeep Sharma from New York. It's our honor for IPSA to organize international seminar on breaking barriers in sciences, a global women breakfast. We are regular organizer of this event. IPS Academy, Indore Professional Studies Academy, is one of the Central India's largest education premises, playing a major role to develop Indore as Central India's most preferred education center. IPSA has established a reputation for excellence and visionary thinking in its effort to improve teaching and learning across our nation. IPSA aims to be one of the premier institutions of the country in pursuit of science, dedication to creation, application, dissemination of knowledge, skill, and spirit of competitive excellence by building up generations of value-driven professionals for the corporate world and the society. IPSA is running 86 courses in 16 colleges. We have College of Pharmacy, College of Commerce, Institute of Engineering and Science, Institute of Management, Arts, Commerce, and there are so many courses under 16 colleges. IPSA has three premises, core premises at Indore. This is the biggest one and established in 1994. We have two more premises, one in Saver and one in Jhabwa. We have 6 Limca Book of Records, 2 Guinness Book of Records. Our Institute of Science and Engineering is NBA accredited. Our Management College is NAC A++ grade. Institute of Science and Research is come under the category of Most Emerging College of India at 9th position. In India Today survey, we stand on 52nd position. Institute of Science and Research, where we belong, has 14 UG and PG courses. We have Masters in Chemistry, Pharmacochemistry, Physics, Biotechnology, and Microbiology, Mathematics. UG courses have different combinations. Our all faculty members, 99% faculties holding PhD degree. We have 14 research guides and where about 20 students are pursuing their PhD. 5 PhD have already been awarded from IPS Academy. We have 2 research centers, one in physics and one in chemistry. We have national and international collaboration. There are 7 government funded projects are already completed. 3 projects are going on, including one from SERP. It's a major research project of worth 40 lakh. We have completed a consultancy of 25 lakh. More than 270 research papers till date have published in reputed journals. On this day, I must say we should never forget the contribution of women scientists in the development of globe. We always remember and pay to our legend in science field. We must pay our honor to
few scientists whose name you must have heard: Marie Curie,
Recording in
Grace
progress.
Hopper, Rachel Carson, Rosalind Franklin, Anthony Helvich, and many more Indian scientists also. I must congratulate Department of Chemistry to organize such beautiful program for women scientists. Thank you very much.
Thank you so much, ma'am. That was indeed informative. Now, it's time to listen to our eminent speaker, Dr. Helen P. Kavita ma'am. She is connected to us virtually, so I request Dr. Reena Jadhav ma'am to kindly come here and introduce her.
Thank you, Nisha. Good afternoon, all. I welcome you all present here in this Global Women Breakfast. I take privilege to introduce our honorable special guest of event who does not need any introduction, known among us for knowledge and wisdom, Professor Helen P. Kavita, ma'am. Head, Department of Chemistry, SRM Institute of Science and Technology, Chennai. Ma'am obtained her PhD degree from Bharathidasan University, Trivandrum. She is life member of IC, ISTE, ICCE and ISCAS. She is a Vice President in Association of Chemistry Teacher Mumbai and Society of Advancement in Chemical Sciences and Education. She is Board of Study member and Doctoral Committee member in various reputed organizations. Ma'am received Best Woman Chemistry Teacher Award for the year 2019 by Association of Chemistry Teacher Mumbai. Ma'am has published more than 60 papers in peer-reviewed journal and presented more than 100 paper in various national and international conferences. She has authored 5 books and carried many projects as principal investigator. So now, we are proud to have such a dignified personality among us. I request ma'am to deliver her talk and enlighten the gathering. Thank you, ma'am, and welcome to the conference. Thank you, ma'am.
Thank you, Doctor, for a very nice presentation. Am I audible to all of you? Am I audible? Am I audible?
Yes, ma'am.
Thank you so much.
Yes, ma'am.
Respected Dr. Premalata Gupta, ma'am, Principal of IPS Academy, Indore. Respected Pratibha Sharma, the convener of Global Women Breakfast, IPS Academy, Indore. And respected Head of the Department of Chemistry, Dr. Ruchi Srivastava. Chief guest of today's program, Dr. Prateek Sharma, was joined from New York. And other speakers, Dr. Shilpi Mishra from IIT Indore, and young rising talent, Mirya Chowdhury. Respected professors, head of the departments, students, and my dear friends. A very good afternoon to one and all connected in a online as well as in the physical mode. At the outset, I would like to thank the organizers of IPS Academy for giving me an opportunity to share my thoughts on this very auspicious occasion of Global Women Breakfast 2023. And this title of this talk is about breaking the barriers in science. And already 3 of your learned personalities, your principal, your head of the department, and the convener has already broken the glass ceiling, and they are in the top. And now they are motivating and leading the young people today here. And once again, I extend appreciation to the Department of Chemistry for organizing this international event. Can I share my slide? My screen visible? Is it visible? Yeah. Thank you. For another 30-40 minutes, I'll be sharing my thoughts about women in science and leadership roles. I could not think of my presentation without remembering or mentioning the legendary poet, Tamil poet, Mahakavi Subramania Bharati, because from childhood I have been memorizing his poems, and he is a very good advocate for women education, women rights, women equal education. And what Subramania Bharati says, பட்டங்கள் ஆழ்வதும் சட்டங்கள் செய்வதும் பாரினில் பெண்கள் நடத்த வந்தோம் எட்டு மருங்கினில் ஆணுக்கிங்கே பெண் இளப்பிள்ளை காடென்று கும்மியடி. What he says, we the women have come to rule scholastically and create the law for this world. Clap and rejoice, for the women are no less than men in reaching the heights of the knowledge. Women are no less than men in reaching the heights of the knowledge. How do you define a knowledgeable society? A knowledgeable society is one which empowers all the members of the society. If all the members of the society is not empowered, then there will not be any social, economic or cultural development. And we know that women constitute 48% of the total population. That means 48% of the human resource of the country. And if this 48% of the human resource of the country is not nurtured properly, we may not have social development, cultural development, or political development. And when you just look back the history, during the early Vedic periods, only few prominent women stand up. And during the medieval period, we know that political and social transformation over the status of women. And again, only in the late 18th century, the education for women is opened up. And by late 19th century, social reforms have paved the way for women education. And there is a participation of girls at all stages of education now. There is a saying, when you educate a man, you educate a man. But when you educate a woman, you educate a generation. Now, 21st century, now we are all enjoying freedom. We are liberated from all the bondages of the past. Now we have access to higher education. We are getting skilled training, and we are getting and women are into venturing into every field, be it piloting aircraft or heading multinational companies, and being a scientist, leading industrial houses, as filmmakers, doctors, engineers, and so on. This photograph, it is said as the most intelligent photo ever taken in the human history. And this photograph was taken during 1927 Solvay Council Conference, and we can see famous scientists Einstein, Bohr, Heisenberg, and Schrödinger are there. In 1927 Solvay Council Conference, there were 29 attendees. Out of these 29 attendees, 17 attendees were Nobel Prize winners. And out of these 29 attendees, we can see that there is only one female scientist who is none other than Marie Curie. Her achievements, we all know that she has got the Nobel Prize twice. When I was just pondering upon this photograph, I was just thinking about Marie Curie. I was just wondering how she was able to get in a place like this, in a photograph, when the entire science community was dominated by women, by men. What made her towards achieving this position? I was just wondering. When we just listen to the history or read the biography of Madame Curie, it was so inspiring, and we could find out the passion that she had for the science and the innovation in science. Let us know what Marie Curie talks about her perseverance and intelligence. And Marie Curie said that with perseverance and above all confidence in ourselves, we must think that we are gifted for something and that this thing should be attained. And she also says that it is her desire that some of us to carry out the scientific activity for achieving your ambition, which could be a permanent contribution to science. And she's really a true inspiring scientist. And there were taboos, and even now there are barriers that sciences are always masculine and arts are feminine. Technical skills are mainly manly and boy activity, and women are not. or they are not competent enough to be in technical activities. But all these barriers have been broken and lot of progress have been made in women education and their role in science and leadership positions. There were many women who have broken these barriers and they have achieved, and we could see many scientists in the past, and we can also see many of them coming up now in the field of science and leadership positions. And when women determined to rise, nobody can stop her against getting that position. We cannot talk about women in science without remembering the legendary scientists of the past in STEM. We talk about Ashima Chatterjee, who is a well-known organic chemist, and Komala Sakhani. She is the first female who received the PhD degree, and Darshan Ranganathan, and she is a chemist. You know, when education was not given to, it was not given that much to the women or girl children. She has gone to London for pursuing her postdoctoral fellow. And even we could not, we know the contribution made by Saraswati Amma and Janagi Amma, the botanist. And even now, for children and scientists, more number of women and girls are into science, and they are doing a lot of contribution to the science. And every year, World Multidisciplinary Journal, which is a very prestigious journal, which is awarding and achieving the women achievers every year. And I would like to quote, I would like to mention some of the women scientists who has received Nature Awards from 2020 to 2021. And the 2022 Nature Award was received by Kismikia Corbett, and she is a professor from Immunology and Infectious Diseases, Harvard PH Scan School of Public Health, and her work was based on Moderna COVID-19 vaccine. And Dr. Kiana Aaron is the proud recipient of 2021 Nature Awards, and her research is based on biosensors for healthcare applications. And Samira is a computational biologist, and her work is based on genomic research. Not only that, our Indian government is also encouraging women scientists at below age of 40 with various awards. And recently, SERV has announced, for the last 2022, SERV has announced Women Excellence Award for 9 women scientists who are at the age of below the age of 40 for the important contribution to science. I have just given the names of few scientists who have received this Excellence Award in 2022. Dr. Chandini, Assistant Professor from Department of Instrumentation and Applied Physics IIC. Her work is based on two-dimensional materials and heterostructures. And Dr. Binita Patel from Assistant Professor Physics. She is working on studying Earth, atmosphere and climate. And Dr. Nikita is also a proud recipient of SERV Women Excellence Award. And we have been stuck with COVID for the past 3 years from 2019. And many women scientists are in the forefront even for fighting against this COVID. We have to appreciate and acknowledge the great work these 4 women scientists have done in fighting against the COVID-19. Dr. Priya Abraham, she's the director of National Institute of Virology, Pune. She is instrumental. She was leading a team which was instrumental in preparing that Covaxin, which will fight against COVID-19. And Dr. Padma Priya, she is the director, National Institute of Research, Chennai, and she is instrumental in, she is leading the team of researchers who are into that preparation of Covishield vaccine. And Dr. Pragya Dhuru, she was instrumental. She is the head biosafety of Pune, level of Pune, and she is instrumental in having the antibody against SARS-CoV-2. And Dr. Nivedya Gupta, head virology ICMR New Delhi, was into preparing that COVID kit. So women scientists are always in the forefront in whatever the social evil that is happening in this world. And sky is not a limit when women is determined to rise. So we know about Tessie Thomas. She is called as the Missile Woman of India, and she's the first women scientist to head the missile project in India, and she's also the Director General of Aeronautical Systems. And she is the proud recipient of Agni Self-Reliance Award in 2001, and she received multiple fellowships and honorary doctorates. And Kuljit Kaur Mas, she is an award-winning planetary scientist. Her research was mainly based on where do elements that form our universe come from. And she is the recipient of many awards, and she is the only person working on experimental indirect astronomy in the country. Ritu Kadriwal is called as the Rocket Woman of India, and she was the Deputy Operations Director to India's Mars Orbit Mission, Mangalyaan. And she is the best recipient of ISRO Young Scientist Award from our former President, then President of India, Dr. APJ Abdul Kalam. Nandini Harinath, she is a prominent name, she is a prominent name among the most Indian women scientists who served as the Deputy Operations Director on the Mars Orbit Mission, Mangalyaan. And in her 20 years of expertise in this ISRO, she worked for 14 missions, and she is a real true inspiration to the female scientists who would like to take up the aeronautical field. Mutaya Vanita, and she is an electronic engineer. She worked at ISRO for over 3 decades, and she served in various capacities, and she has received the Best Women Scientist Award. And we cannot resist appreciating Mangala Mani, who is called as the Polar Women of ISRO. And even at the age of 56, she has been given an assignment to go to the icy landscape of Antarctica. She, with her 23 team members, went there, and she spent nearly 43 days in the southernmost continent for operating and maintaining this ISRO ground station. Really, it was a remarkable contribution by a female scientist. Aditi Pant is a successful oceanographer, and she is the first woman to visit Antarctica in 1983 as a part of this expedition to study geology and oceanography. And she is also worked the US government scholarship to study MS in marine sciences. And this madam, Dr. Chandrika Shaka, she is the biologist and the first ever women president of Indian National Science Academy. And in the 85 years of existence, the Academy had never had a woman president until she took over. And she is a recipient of various awards. And she has been awarded, she was awarded a special award in 2003 for a significant contribution towards understanding the cell death processes in different model organisms. And she is also served as a vice president of INSA between 2016 and 2018. You know Ganga Deep, a virologist and scientist, and she is the chairperson of World Health Organization. Sita Kolamin, she is a chemist, environmentalist, and an entrepreneur. And she worked in a Royal Dutch Shell, and she became the head of the she was using lot more qualities and varieties of plastics. And when she visited India, she realized the damage that plastics have made in the environment. She wanted to do something for that. So she started an organization called as Simply Sustain. It is a firm that is focusing on industrial ecology and assessment of the life cycle of the products. And the contribution for this environment is really remarkable with that Sita Koliman. And Bushra Atik is a cancer biologist, and she has done a wonderful job. She has done research on genetic abnormalities that cause cancer. And she received Shanti Swarup Bhatnagar Prize from Science and Technology. And she is selected as the prestigious Sun Pharma Science Foundation Research Award in 2021. And she is featured in Indian Women in Science 2020-2021 by Life Sciences. Parimala Raman, the recipient of multinational and international awards. And in 2020, a Government of India announced the establishment of 11 chairs in the name of Indian scientists. And she is the only person living on the list. And in 2010, she received one of the highest global honors in mathematics. Nilina Gupta is again the third and the fourth Indian to receive the prestigious 2021 Ramanujan Prize for Young Mathematician for the developing countries. She is also the recipient of Shanti Swarab Bhatnagar Award in 2019 under the category of Mathematical Sciences. And this doctor, I would like to have a special mention about Vishwanathan Shanta, who is a chairperson of Adayar Cancer Institute, Chennai. She dedicated her whole life for making quality and affordable cancer treatment to all the patients of the country. Till her last breath, she was working in the hospital and she was helping people to give quality treatment to the patients. And she is the recipient of second highest civilian award given by the government of India, and she also received several awards like Padma Shri, Padma Bhushan, Padma Vibhushan, and Magsaysay Award, etc. And Dr. Kamala Selvaraj is also from Chennai because she's a doctor, oncologist, obstetrician, and a gynecologist, and she was working on test tube babies and couple who are deprived of children or getting really happiness when visiting her lab, and she was able to give more than 800 babies have been born as a result of the assisted reproduction therapy conducted in a hospital. Having said all this, we have only few notable women in the past, and the number is slowly growing. But when you see the statistics of the enrollment of women in science, it is gradually growing in undergraduate, PG, MPhil and PhD. But when it comes to postdoctoral fellowship and above including the researchers and faculty, the growth is less when compared to undergraduate program. So this is the data given by DST in a recent 2022 one. And according to this, the overall participation in science and sector and women principal investigators in R&D has almost 4 times. It has increased 4 times. In 2001, the number of principal investigators is only 232. Whereas according to the statistics in 2016-17, the number has 4 times increased and it becomes 941. It is 941. And similarly, the number of women researchers in India is also doubled from 2014 to 2022. In 2014, there are only 30,000 women researchers, but in 2022, we have 60,000. And the women participation is the highest in biotechnology, counting about 40%, and in medicine it is 35%. Specifically talking about the Department of Science and Technology, and the data says that out of 97 scientists in Department of Science and Technology, 35 are women, and the big achievement is that out of 18 divisions in the DST, 11 divisions are headed by women, which is probably 61%, which is more than 50%, and this is the largest percentage of women in leadership in any government department. It is a very welcoming sign for women in science. And these are the 11 chairs named after the women scientists. Kudos to the scientists. And then this is a global scenario about the women participation of women in STEM occupation. When we talk about the STEM occupation globally, we say that 46% of women are occupying biological sciences, 40% in chemical sciences, and in mathematical sciences is 25.5%, and as engineers and other architects, it is 16.5%. So when we talk about the participation of women and girls in STEM globally, and 15% of the college-educated workforce are women, and 5% of mathematician and statistics students globally are women. According to Yale Scientific, 25% of women, adults are in the scientific education according to 2016. And according to UNESCO, it is 23% of women researchers are paid worldwide. And when we come to CEOs in the STEM industry, we have only 3% of women. And this area we have to really look into. And gender in science, innovation, technology and engineering. In collaboration with Inter Academia Partnership, we have conducted a survey, and 120 national academies have participated in the survey. And even in that survey, the results, the report says that the participation of women across the country is low. And this is the statistics data that is given about the members of national academies from 2015 to 20. When we see that the participation of women in these national academies, like USA, Australia, you can say that it is 15%, and Brazil it is 15%, in Canada it is around 20-25%. When you see the number of women in India, it is only 6% in 2015 and 9% in 2020, which is the area which we really have to look into it, and it is a gray area where women have to really see about it. And women's representation among the governing body of academics, and again we can say that only in USA, which is about 59%, and Canada it is 55%, remaining countries are less than 50%. As we know that there is a growing number of women participation in undergraduate, postgraduate and doctoral energy levels. And one of the happiest things when we see the statistics globally, there are 43% of STEM graduates in India are women, which is the highest in the tertiary level around the world. You see, there are some data which is given here in the slide. We have US, Germany, UK, India, and India is having about 43% of STEM graduates, which is really a welcoming sign of women in science. But the concern is, and there is a report says, out of these 43 STEM graduates who have taken the undergraduate and postgraduate things, only 14% of women are into STEM jobs. The question arises here, what happens to the remaining percentage of women who have taken up science as an education? There are two major issues that stand up in this. One is related to the entry and retention of women in science. This really, we have a concern, because when we're talking about the entry and retention of women in science, up to post-graduation, girls are in equal ratio or almost an equal ratio with boys. When we come to entry level into PhD, the number is less. Women joining PhD and men joining PhD, boys joining PhD, there is a variation. But when we come to entry level into the occupation, so occupation or job begins only at the age when after the PhD. But this age, after completing their PhD, this is the age where women have to get married and settle in life. They have to go for childbirth. So automatically there is a gap. They have to take a break for 3 to 5 years to take care of the home responsibilities, to take care of the children. So there is a break that is existing. By the time when boys can go to PDF, so a lot of in that gap that happens between women taking a job at entry level and men taking a job at the entry level. Even there is a statistics which I have not given here, and there is an article which is telling about the publication gap between the women scientists and the men scientists. There is a lot of publication gap. Even COVID has affected the publication capacity of the women. So this is happening, which is happening in the entry and the retention, and because of that, women are not able to progress in equal thing as that of the women, and therefore there is a difference in the career attainment between the men and the women. But what to do with that? Women cannot forego getting married, or they have to take care of the child. But this position we have attained, this stage we have reached, though these things are there, we are able to achieve this much. And some earnest efforts are taken that I'm going to discuss in the next slide. And this ratio will go, and there will be a merging of gap between the women in the top managerial positions. And during the talking about the career leaky pipeline in the career attainment, in IIT Madras, out of 304 professors, only 31 professors are women. And to date, none of the IITs or prestigious institutions or Indian Institute of Science or Tata Institute of Fundamental Research has had a women director. And even in IIT Bombay, only 25 women are there out of 143 professors, which constitute only 17.5%. And IIT Madras, we have only 3 out of 53 chairs that are held by women. And ISC, just 1 out of 9 chairs are the women scientists. And even in ISRO, there are scientists. and the women employees in administration is only about 17.6%. And women are also unrecognized for the scientific advanced achievements, maybe in Young Scientist Award or National Bioscience Awards. We have low participation. There is a gap. There is a gap in publication. There is a gap in patenting. There is a gap in the career advancement. How to go about it? How to solve? How to bridge the gap? How to narrow down the gap? And we have come across long way in our journey for our equal thing. But even certain things, again, we have to, the society has to really liquidate if they really want the total success of the women in science. Stereotypes. Certain stereotypic thinking are there, even in educated men, I would say, or educated women. Even in educated women say that don't take this role because it is not our thing. So stereotypes are there. Patriarchy is there. Society, there are not role models. They say don't go that. Then your age will not. I will just come to one example afterwards. Unnecessary fear about competence, stress related to marriage and childbirth. And if any lady is giving a lot of importance to profession, then she has to forego the family. Then people will tell you are not taking care of the family. You are always into the profession. How your family will be that? Lot of stress has been created in the marriage and childbirth, household responsibilities, physical safety, harassment. All those are making low participation of women in science. How to close the STEM? Anyway, the gap has to be closed, and women has to get the position what they really wanted to have. Raise awareness among the girls. I think that this should start from the home. Even parents should treat the girls and boys in a home an equal thing. And they should not discriminate by assigning the work that you have to do this and this has to be done by a boy. And they have to be treated equally. Then even a boy and the girl will realize that I am equal to boy. At any point of time when they go to any institution or they work, they should not say anything, oh, this is not my job, let the male counterpart do it, I will not do it. So that thought process should be eliminated even from the home, and they have to give confidence. They have to give give them freedom for to have their own choices, whether it be selecting a course for their study, or selecting a job they wanted to go, or selecting the place of their work. Let them be given a chance of freedom, and promote awareness among the parents. Show visible role models. Normally, girls are attracted towards role models. They wanted to behave like the one whom they like the most. So give them a lot of role models so that they will take them and they will follow it. Provide relaxation in age, and a lot of things are happening. The DST also is supporting women in all relaxing ages, and accommodate career breaks. That has to be taken into account, especially in service also. If there is a career break for women, that has to be considered while a woman is considered for promotion to higher levels. Improve job hiring, recruit more women people in the institution, and provide professional development programs, and promote a welcoming work environment. And lot of initiatives have been taken by Government of India, and Vigyan Jyoti scheme, we have Dept scheme, we have knowledge involvement research advancements called Kiran scheme, which is for the women scientists to move up the academic ladder, and more than 2,200 women scientists have been benefited. And we have a mobility program, and this program especially for the women scientists who have a reallocation problem, and there is a QRI thing. And now DST is implementing, is insisting upon the institutions to have more women in leadership positions. Almost 30% of women should be there in the decision-making roles. Right. And coming to leadership roles as women, as entrepreneurs, as company CEOs, and leadership is not about gender. It is about the inherent, leadership is something about inherent quality a person possesses. And when you have women leaders in any organization, and you are fortunate that all your leaders are women, your principals, your conveyor and everybody. And if women are there in the decision-making roles, then effective decisions can be taken in any organization. But though we say it is an inherent quality for a men and a women, and women show transformational leadership. What do you mean by transformational leadership? This leadership is not only about accomplishing the goals of the organization. She wants the entire colleague to grow along with her. And she functions as the role model. She supports the subordinates. She supports her colleagues. spent lot of time in coaching, and together this organization will grow. And women are task force leaders, and they are able to keep up the time and finish everything in time, and they promote collaboration and coordination. Are women great leaders? Yes, of course, women are great leaders because we have so many qualities with us. We are empathetic. We would like to listen to what others are talking about. We care about others. We are multitasking. We are able to do many things at a time. And and even if you are leaving your house for one day, our people at home cannot do it. But we are able to effectively manage home as well as effectively manage the institution in which we are working, and we are able to bring laurels to them. And they are motivated by challenges. If somebody challenges you that you cannot do it, we really look into it and see that we are able to do it. We value work-life balance. We handle the crisis very well. Actually, we say that women are very fragile and we are low-hearted. It's not like that. When any crisis comes, they will stand in that and they will prove their mentorship. And they are flexible and they do their job effortlessly. And here I will take another few minutes to wind up. And we have very influential women leaders with us. Dr. Soumya Swaminathan, she is the chief scientist of WHO since March 19. And Sikha Sharma, she is the managing director of CEO of Axis Bank from 2009 to 2018. And we have Leena Nair, and she is the British Indian business executive, and she is the youngest and the first female global CEO of French fashion house Chanel, and she has got many applauds. And she is featured in Fortune India, Most Powerful Women in 2021, Role Model of the Year 2021, Fortune India's Most Powerful Women 2021, and the list goes on and on. And Urvi Piramal, her story is really inspiring. She took over the family business when she was widowed at the age of 32. She took over the Ashok Piramal company, and she has taken to a greater heights. And we know Kiran Muzamdar, she is a very powerful lady of India. She is the chairperson of Bicon Limited, and she is ranked as the 68th most powerful women according to Forbes. And we all know about Indra Nooyi, the most powerful woman of the world, and she is the former CEO of PepsiCo. She has received many awards from the government of India. And she is the proud recipient of 11 honorary degrees from different prestigious institutions. Roshni Nadar, she is from my place, Chennai, and she is the chairperson of HCL Technologies, and she is the first woman to lead an IT company in India. And having said all this, the number of women in top positions or managerial positions or decision-making roles is very less. The data says that it is only 15% of board members and board chairs are held by women, according to a survey in 2019. According to a global survey conducted by Grant Thornton, India is ranked the third concerning the women in leadership roles, and only 17% of the senior management roles are played by women. And even the number of participation of women in Lok Sabha and Rajya Sabha is not so encouraging. You can see the graph. In 1952, it is 6.9, and even in 2004, it is somewhere around 12. And this is the case with Lok Sabha and in Central Council of Ministers. Do we need more female leaders? The answer is yes, of course. We need more female leaders. How do I get it? Recruit more employees. Have more leadership roles. Give them more leadership roles. Establish a mentor system. Once in a year, we used to conduct programs like this. So the mentorship program should be continuous and identify some senior position in any organization who can be elevated to a higher level, who can really function as a leader, give training for them. And what are the key steps we have to take to be a strong leader? Remove unnecessary fear. And there is a study that states that if there is a job vacancy and men will apply if they have only 60% of the qualification, whereas a woman will apply for that position only if she's having 100%. And that is a profession we always require, which we have to slowly get out of. We have to compete. And Reshma Saji, a founder of CEO of Girls Who Code, says that we want always the girls to be smiley, we want to be pretty, we want to get all ways, and we taught our boys to be rough and swing. We have to make our girls mentally strong, rough and ruggy sometimes. We have to come out of the comfort zone. Many leaders, they have achieved because they have come out of the comfort zone. We have to encourage women-friendly culture in any organization, and gender equality is inseparable part of human rights, and we have to fight against any injustice or violence that a woman in society is facing. And to be liberated, we must feel free to be herself, not in the rivalry to men, but in the context of her own capacity and personality. There is no force equal to women who is determined to rise. A strong woman stands up for herself, a stronger woman stands up for everyone else. In our journey for success towards equality, we want our father to be with us. We want our brother to be with us. We want our husband to be with us, to hold our hands, to walk with us, to be success in the journey. To pat on my shoulders and say, just go ahead, you are able to do it. To be by my husband, to hold me and say that I am with you in the times of hardships. The distance we have traveled all these years to reach the position what we are today is too long. And the distance I have to pass is also very long. I totally conclude my words with a poetry from Robert Frost. The woods are lovely, dark and deep, but I have promises to keep, and miles to go before I sleep, and miles to go before I sleep. Once again, I thank the organizers for giving me a wonderful opportunity to share my thoughts in this August gathering in a very auspicious moment of this Global Women Breakfast. Thank you all. Thank you so much.
Congratulate to Dr. Dept from Chennai for delivering such a beautiful and enthusiastic lecture for women itself.
Not take away long.
Am I able to listen?
In case of the place.
Am I audible?
I'm not able to hear anything she's talking about. Take it away. I'm not able to hear. Yeah.
Thank you so much, ma'am.
Oh. Maybe stop share பண்றது.
பாருங்க எல்லாமே நான் அதெல்லாம் எடுத்து பார்த்தோம்னா இதுல இருந்தா வாசி தெரியுமா இருக்கு.
Yes, I'm able to hear me. Can you able to hear me? Thank you so much. Thank you. I'm hearing you. Yeah, thank you. Can I just, thank you so much. Stop on me. Thank you.
About the great contributions of women in field of chemistry and science. The information you shared will surely increase knowledge of all. Thank you, ma'am. If you are not willing to learn, no one can help you. If you are determined to learn, no one can stop you. With this thought, let's proceed forward and have an interaction with our eminent speaker, Dr. Shilpi Mishra ma'am from IIT Indore. I request Dr. Reena Jadhav ma'am to kindly reported an isolable and bottlable NS
exceptionally stable. Metal carbenes give high thermal and hydrolytic stability, long shelf life, and resistance to oxidation. Nowadays, NXC is not only the alternative to the phosphines, but they are sometimes a better choice. Therefore, NXC replaces phosphine in many organometallic and organic reaction for several reasons. One of the reasons is NXCs are very easy to make on larger scale. And second, the salt of carbenes are stable without decomposition in air. And there is no need to add excess NHC ligand in the reaction. Now I am going to discuss the reactivity difference between the phosphine and NHC ligands based metal complexes. First I am going to take the example of Sonogashira coupling, where this inactive bromide treated with this terminal ions in presence of a ligand to form a substituted alkyne. If you do this reaction in presence of phosphine ligand, the yield of the reaction is less than 5%. If you replace this catalyst in presence of NSC ligand, the yield of reaction increases from 67 to 80%. And another example is the classic example of this evolution of Grubb's second generation catalyst to the Grubb's first generation catalyst. In the Grubb's first generation catalyst, if we can see, there is two phosphine ligands. And in Grubb's second generation catalyst, one phosphine ligand and other is NSC carbene. So in those reactions which are not accessible with the Grubb's first generation, you can easily accessible with the Grubb's second generation catalyst. So now we can say that for NHC is far better than the phosphine chemistry. What are NHCs? NHC is a type of carbene. So let's discuss the carbene first. So carbene is a neutral divalent carbon species having two non-bonding electrons and 6 valence electrons. These two non-bonding electrons either be paired as singlet or unpaired as a triplet. If it is in singlet, then it is in sp2 hybridized, leaving this p orbital empty. And if it is in triplet state, it is in sp hybridized and work as a divector. These carbenes are highly reactive and short-lived. That is why it is very difficult to isolate it. It has 6 electrons in the valence cell. Therefore, it has a high tendency to gain 2 electrons and complete the bond. These are the examples of some classical carbenes like methylene carbenes and difluorocarbenes. Methylene carbenes are stable in triplet state, whereas the difluorocarbenes are stable in singlet state. These are the classical reaction of carbene. First is insertion of carbene into a sigma bond. Commonly known reaction is homologation. And the second, insertion of carbene into a pi bond. Formation of cyclopropane. Common reaction is Samson-Smith reaction. In crash reaction, carbene rearranges with the cyclopropane ring to form a alkene. And in dimerization reaction, carbene undergoes self-dimerization. And this is a very common reaction of carbene, Wolff rearrangement, where the carbene rearranges into a ketene. Now, what are the factors which can affect the singlet, which can affect the spin state of the carbene? There is two spin state of the carbene, singlet or triplet. Then what is the singlet state? When it will be the singlet or the triplet? So there are many factors which can affect the spin state and the property of carbenes. There are solvent, there are dihedral angle, and the substitution effect. I am going to discuss the most promising effect, that is substitution effect. Substitution effect is of two types. Steric effect, which deals with the crowdiness and bulkiness of the ligand. better electron donor, and the low LUMO energy carbene is better electron acceptor. These are two types of carbene in the literature. One is acyclic, another is cyclic. Cyclic carbenes are stable than the acyclic carbenes. These are the acyclic carbene where this carbene center is associated with the nitrogen. Here phosphorus and silicon, and here phosphorus and the carbon. These atoms near to the carbene center play a very important role in the stability of carbene center, as I showed in the last slide using this inductive and mesomeric effect. These are the cyclic carbenes. Like this is diamino base carbene, this is imidazole, this is benzimidazole, this is trizole. There is another class of cyclic carbene when this nitrogen atom is replaced with a sulfur. It's called thiazole based carbene. And when the nitrogen atom is replaced with this tertiary carbon, it is called CAAC, cyclic alkyl amino carbenes. In 2005, Guy Bertrand reported the preparation of new class of carbene that is called CEAC. Since then, CAC became most important and the popular tool in various branches of chemistry. This is the structure of NHC, where this carbene center is attached to the two nitrogen atoms. These nitrogen atoms shows push and pull effect. This nitrogen attracts the electron through inductively and show the pull effect, whereas the lone pair of nitrogen donates to this p orbital of carbene center through mesomeric effect and show the push effect. Like this, it shows pull and push effect. In the CAC, where the nitrogen atom in NHC is replaced with the tertiary carbon atom, alpha to the carbene center. Here the nitrogen is attracting the electron and this quaternary center is donating the electron via inductive effect. The single nitrogen atom donates the lone pair of electron to the empty p orbital at the carbene center. That's what it is stabilizing the carbene center. Now we will see the comparison of NHC and CAC carbenes. So as I told you that in CAC, the nitrogen of NHC is replaced with the quaternary center in CAC. In other words, we can say pi donating and sigma attracting amino group is replaced by sigma donating quaternary carbon atom. And this structural difference reduces the homo-LUMO gap. Like the homo-LUMO gap in NHC is 68. Where is the mouse? The homo-LUMO gap in NHC is 68 kcal per mole and the homo-LUMO gap in CAC is 46 kcal per mole. In other words, we can say CACs are more electrophilic and nucleophilic than NHC, or CAC shows a strong sigma donating and enhanced pi accepting properties. This is the reactivity difference between the CAC and NHC. Here I am taking the example of ring closing metathesis reaction. So the reaction is performed with both the catalyst, Grubbs-Hoida catalyst and the CAC based ruthenium catalyst.
the product is obtained in the quantitative yield with both the catalyst. But if you can see that with the Grubbs Hedla catalyst, the RCM product is 34% and the non-metathetic product is 58%. And when you do this reaction with CAC ruthenium base complex, the RCM product is 87% and the non-metathetic or the isomerization product is 13%. So you can say, in other words, that NHC is better than the phosphine, but CAC is doing far, far, far better than the NHC and the phosphine chemistry. So these are the different types of CACs reported in the literature. CAC5 with 5-membered ring, CAC6 with 6-membered ring, bicyclic CAC with 2 rings. And this is FUN CAC, short form of functionalized CAC, where this center is attached with the different functional groups. When this alkyl group is replaced by the aromatic group, then it is called cyclic amino aryl carbene. And when this amino group is replaced with the amido group, it is called cyclic alkyl amido carbenes. So I am going to discuss the synthesis of these carbenes one by one. In 2005, as I told you earlier, the chemistry of CAC is very new. So first, the Guy Bertrand and the co-worker in 2005 reported the synthesis of this CAC5 using the method A. And in 2007, they reported the synthesis of CAC5 using the method B, which is also called hydroiminium route. Here the Dept NH2, which is known as diisopropyl phenyl NH2, treated with aldehyde in presence of magnesium sulfate to generate the imine. And then imine can be converted into this iminium salt using 2 methods. First is with deprotonation with aldehyde, followed by the addition with isobutylene oxide and triplet anhydride to generate the corresponding salt. Whereas in the method 2, imine was deprotonated with LDA or N-butyl lithium, followed by alkylation with halopropene to get this alkenyl aldamine. And this alkenyl aldamine undergo hydroamination reaction in presence of HCl in diethyl ether to generate this iminium salt. Once you get the iminium salt, you deprotonate it with LDA to generate this CAC5. The synthesis of CAC6 is almost similar to the synthesis of CAC5. The only difference in this synthesis is that in the synthesis of CAC5, they have used halopropene. Here they have used the halo or isobutene. The other steps like acid catalyzed cyclization or deprotonation is almost the same. They have used different type of aldehyde in this reaction. Bertrand and group in 2017 describes the synthesis of bicyclic CAC precursor. Here the trivirtal condensed with Dept NH2 under SD condition to generate this imine. An imine followed by this deprotonation and the alkylation with alkyl halide generate this alkyl aldamine. If you notice in this alkylation, they have used RX, not this haloalkene or halopropene, halobutene, because this is already a cyclic structure. And then the endocyclization of this alkenyl aldamine in presence of HCl and ether generate the corresponding salt, which on reaction with lithium HMDS as -78 degrees centigrade generate the bicyclic carbenes. This is the synthesis of functionalized CAC. Here the Dept NH2 was treated with unbranched aldehyde, that is propanol, to get this aldamine. And aldamine was deprotonated and alkylated to give this alkenyl aldamine. And this alkenyl aldamine can be converted into the this iminium salt using two methods. The first method is the deprotonation with N-butyl lithium followed by the alkylating agent carrying a functional group to synthesize dialkynyl aldamine, which undergo cyclization to generate this this iminium salt. Whereas in second method, this alkynyl aldamine undergo proton-induced cyclization in presence of ammonium hydroxide to generate this enamine. And alkylation of this enamine with different alkylating group carrying a functional group generate the corresponding iminium salt. Bevlowski and co-worker in 2016 describes the synthesis of cyclyl aryl amidocarbons. Here, the tetramethyl gluteryl dichloride was treated with DPNS2 to generate the dione, and dione was undergo partial reduction with dibal and chlorination with thionyl chloride to generate the precursor for the amide carbene. In the synthesis of aryl carbenes, 2-bromo-benzaldehyde was condensed with DIP to generate this imine. An imine was treated with N-butyl lithium followed by the addition with benzophenone and triflic anhydride to generate this isoindolium salt, which on treatment with lithium HFDs generate the corresponding amine. Till now, so far I have shown you the different CAC carbenes and the synthesis of those CAC carbenes. Now I am going to show you the use of those CAC carbenes in the synthesis of metal complexes. As I already discussed, the synthesis of this aryl carbenes and which is more electrophilic than the CAC5 or CAC6. When this isoindolium salt was deprotonated with lithium HMDS followed by the addition of this rhodium precursor, generate the rhodium CAC based carbene, rhodium CAC based complex, and this complex is air stable, which can be further investigated for the alkylation reaction and 3+2 cycloaddition reaction. Alkylation was carried out via CH activation, and this newly synthesized rhodium metal complex activate the terminal vinyl bond and facilitate the reaction between the vinyl pyridine and the alkene. Similarly, this rhodium metal complex also catalyzes the reaction between the cyclopropanone and alkyne to give tetra substituted pentanone. This is the synthesis of functionalized CAC chromium complex. This is functionalized CAC, where side chain with functional group is attached, and this convert this monodentate CAC to bidentate CAC. Because the nitrogen atom of this side chain also participate in the coordination. This functionalized iminium salt treated with potassium HMDS followed by the addition with chromium trichloride to generate this chromium complex. And this chromium complex can be used for the deoxygenated hydroboration of nitroarenes and nitroheteroarenes. In this reaction, HBpene and the manganese act as a reductant. And this chromium complex has been used in various aromatic and heteroaromatics with the other reducible functional group attached. However, the other functionality always keep intact during the reaction, and only the nitro group converted into the amine. This iron CAC complex was synthesized by the Mandal and co-worker in 2016. Here the CAC5 was treated with Fe2CO9 in toluene, and the reaction was stored at room temperature for 16 hours to get the iron complex. And this iron complex has been utilized for the dimerization of terminal alkyl arynes. This reaction involves head-to-head dimerization of aryl alkynes toward the conjugated enions with high E selectivity. In this reaction, the E isomer has been isolated in 84% yield and the Z isomer isolated in 16% yield. This reaction involves very low catalyst loading of 0.2 mole% and with the high torn of 6,500. This is the synthesis of bicyclic palladium complex. Here the bicyclic carbene was reacted with palladium chloride and reaction was stirred for 5 to 6 hours to get the complex. And this complex can be used for the catalysis of Heck reaction and Suzuki-Marua cross-coupling reaction. The Suzuki cross-coupling reaction or the cross-coupling reaction and the CH activation are very important reaction in organic chemistry. This catalyst, it is important to note actually, this catalyst can work in an open air condition and with a low catalyst loading of 0.5 mole%. In the Heck reaction, aryl bromide and the olefin with different substituent undergo this reaction and deliver the substituted alkene in high yield. Similarly, the Suzuki coupling of phenylboronic acid and the aryl bromide performed well under the similar reaction condition. Zen and co-worker in 2015 synthesized the CAC rhodium complex. Here the iminium salt was deprotonated for the reacted with the rhodium cord complex to get this rhodium CAC complex. And this complex can be used for the synthesis of selective hydrogenation of aryls. The aryl ketone could be selectively hydrogenated to cyclohexyl ketone keeping this carbonyl group intact. Similarly, the phenyl group can also converted into the cyclohexanone. This selective hydrogenation can be implemented on the larger scale and conducted up to 10 gram. When we are talking about the metal complexes and the stability of metal complexes, we should always consider the ligand attached to it because it really plays important reaction in the stability. For example, the metal complexes with the multidentate ligand are more stable than the complexes with monodentate ligand. Because in case of monodentate ligand, if the ligand dissociates from the metal center, there is no chance that it can attach to again to the metal center. In that case, metal complex deactivated and reaction will not proceed further. Whereas in case of multidentate ligand, if the one arm of the ligand dissociate, however the other arm is still attached to the metal, and it is very difficult to remove both the ligand from the metal center. In that case, reaction continues without being decomposition of metal complex. In last few slides, so you can say that multidentate ligand play an important role in complex stability because it provide a powerful platform for the synthesis of robust transition metal complexes over the monodentate one. And if you have seen the last few slides, I have given you the idea of the CAC metal complexes. But if you have noticed, those metal complexes are monodentate, except the only one, the functionalized one. Because the multidentate CAC ligands are unexplored till now. If you will go into the literature and find out that the multidentate phosphine chemistry is very well known and established, and the multidentate NSC chemistry is growing really fast. However, the multidentate CAC chemistry is not explored till now. So therefore I decided to work on the multidentate CSE ligands and their complexes. So till here I give you the background of the CSE complexes because it is very new. Now I want to give you a very brief introduction of the research, what I am doing it. So currently I am working on the design and the synthesis of pincer CSE ligand. So this is the strategy to which we can make this multidentate CSE ligand. This multidentate CSE iminium salt can be synthesized by the acid-catalyzed cyclization of this dialkynyl aldamine. And this dialkynyl aldamine can be synthesized by the alkylation of this alkynyl aldamine on the anchor unit. And this alkynyl aldamine can be synthesized from the amine, and this amine can synthesize from Dept NH2 and propanaldehyde. If you can notice, I am using here two alkylation. This is the first alkylation. Alkylation of this amine with this chloropropene to get this alkynyl aldamine. And in second alkylation, I am using this alkene aldamine with the anchor unit. And as you know, research is not easy. If you want to do some research, you see a lot of failures. So these are the efforts or my attempt to synthesize the carbene precursors. So at the first, we have synthesized this alkene aldamine by the condensation and the alkylation of Dept NH2. Once we got this alkynyl aldamine, then we have to try different type of alkylation reaction. So here first I use this silicon dichloride in presence of N-butyl lithium. But this reaction did not work with N-butyl lithium and with other bases also. Then I changed my alkylating agent to diadomethane. And here also the starting material was recovered, but reaction did not work. I tried different conditions using the solvent, temperature, bases, but this reaction did not work. Only the starting material was back at the end of the reaction, no matter how long you do that reaction. Then with the hope that this reaction might work, I changed my alkylating agent to tosylate because tosylate is a good leaving group. But here my starting material decomposed. So since my second alkylation strategy on the anchor unit is not working, it's really high time for me to change some other route. Then what I did, I reversed my strategy. In here I'm using this alkene aldamine and doing the second alkylation on the anchor unit. Here I took the anchor unit first. I use this anchor unit as 2-aminopyridine and 2,6-diaminopyridine. And condensation of this aminopyridine in magnesium sulfate generate this amine. And amine can convert it into the alkynyl aldamine using the deprotonation and the alkylation reaction. Once we got this, I want to do the acid-catalyzed cyclization on this alkene aldamine. But when we do this reaction, we find out the precipitate, but that salt did not correspond to this iminium salt. We did this reaction 3-4 times to find out the real problem. But the NMR showed us that we are getting the salt of this alkynyl aldamine because as soon as you are adding HCl into the pyridine, the hydrogen attached to the pyridine and this alkynyl aldamine precipitated out as a salt. Here the problem again. Then I changed my strategy. Here I am not using the as hydroaminium step for the alkylation reaction. As I showed you in the last slide that this alkene can be actually amine can convert into this iminium salt using 2 steps. The first one is isobutylene and triflic anhydride one, and the second is deprotonation and alkylation, and this hydroaminium emanation route. Usually people prefer the second route because it's a cost effective. Route 1 is very costly because we are using isobutylene oxide, triflic anhydride. Since my second strategy with this hydroaminium route is not working, so I tried this. Oh my God. So I tried this isobutylene one. So here the amine, amine is treated with isobutylene oxide, triflic in presence of LDA, followed by triflic anhydride to generate this bidentate ligand. Similarly, I have synthesized this multidentate CSE ligand. So as we have synthesized this bidentate and tridentate ligand, we have prepared the ruthenium-based complex of these ligands. And right now, we are trying to do the different catalysis with these metal complexes. So in summary, the rise of new family of carbene ligands, CSE, has been described. CSE are more nucleophilic and more electrophilic than the diamines. The presence of quaternary carbon provide alpha to the carbene center, provide the steric and electronic environment that differentiate CSE dramatically from the other ligands. This unique property of CSE makes carbon-metal bond very strong, and the CSE metal complexes are very robust. These metal complex covers a vast area like coordination chemistry, bio, inorganic chemistry, medicinal chemistry, and the material sciences. Finally, I would like to thank Department of Science and Technology, New Delhi, and Department of Chemistry, IIT Indore, and Professor Suman Mukhopadhyay to provide me lab as my co-host, Dr. Premlata Gupta, Principal, IPS Academy, Dr. Ruchi Srivastava, HOD Chemistry, and Dr. Pratibha Sharma for organizing this nice event and for inviting me. And thank you, audience, for bearing me. Thank you so much. Yeah.
Thank you so much, ma'am, for your special message.
Thank you so much.
I
hope I delivered it good. And actually, this is very new.
Thank you so much, ma'am. Thank you, ma'am, for coming at IPS Academy and share your knowledgeable lecture and presentation on carbenes. Thank you so much. I know you are sitting out from last 2 hours, I think from 2 p.m. So you are hungry also, no? Now, a very interesting lecture on simulation of GI tract in chemistry lab from our eminent guest, Dr. Pradeep Sharma, sir. So though I'm not taking any formalities to introduce, sir, start his lecture on simulation of GI tract in chemistry lab. I think it is very interesting lecture. You all should listen it carefully. Thank you, beta.
Good afternoon, everyone. Especially staff and students. And my respect to Principal Dr. Premlata Gupta for leadership and fostering the scientific environment. It's really very, I have a high respect for that. And Dr. Srivastava for organizing these events, and then the achievement of chemistry department reading is because I know I belongs to chemistry faculty, so it's chemistry discipline, so I know that it's a really remarkable achievement of chemistry department. And Dr. Pratibha, she took a weekends, a lot of calls back and forth, her dedication towards this organization to organize this event and IPS Academy is really very contagious, and I have high respect for her dedication, and my respect to Dr. Kavita for very insightful, eye-opening presentation, and Dr. Mishra remind me my college day of chemistry. So, and my very good afternoon to all students of IPS Academy. Because 30 years back, when I used to commute to my work, at that time, IPS Academy was a very beautiful building. We were not able to resist our eyesight, and we saw, and it's a very reputed academy at that time in 1995, 1996. And really, I'm very proud of achievement of IPS Academy, and I know that why it is a great institution. So here, I would like to share. Yeah. After, is everybody is able to see it properly? Hello? Hello. So, after discussion with Dr. Pratibha Sharma, I thought I just share something which I can be really useful. I'm very privileged to work in India around 10 years and 15 years in the US. So, and after this discussion with Dr. Sharma, I thought that nowadays information are click away. So I don't want to be overwhelmed with information. So genuinely, whatever I saw in industry and what is striking me, I would like to share those information. And so before going to this simulation, my my favorite subjects, I would like to, as an insider, I would like to share some information, and it may you know already, so forgive me. I have thoughtfully think about it. The entire typical drug development programs in industry have two categories. One is NDA and second is ANDA, which is very popular and known as a generic. So in new drug application, there are two categories, new chemicals, which is obvious. It's a new chemical entities for new indication, new disease, and it's very complex process, and it took around 10 to 15 years to come up with new drugs, and it required heavy duty organic chemistry, lot of toxicity, safety studies, and everything. Second category is new dosage forms, means we convert tablet to injections, tablet to syrup, or some new indications, or some modifications, some combination. We reduce the doses 3 times to 1 times, like this. So those are the two categories of NDS. And in generic, it's a very around 90% pharmaceutical industries are involved in this R&D development program of generic. So this is there are two categories before expiration of patents. Means there is a 5 to 10 years patents granted, but if there is a way to develop non-infringing formulation, and so before even expiration of patent, generic companies can launch their products. And another is after expiration. That's very popular. And after expiration, there is no patent restriction. So just simply we can copy. Because in difference between NDA and generic is, generic has a low developmental cost because there is no burden of proving the efficacy. And NDA has a burden of to prove safety, toxicity. Safety means with respect to toxicity and efficacy. And it required phase 1, phase 2, phase 3, and it's very expensive and time consuming development program. So that's why government usually protect them and reward them as a patent. So 5 to 10 years, it's all also. And but in generic industry, generic filing, we have generic sponsors has to only oblige to prove bioequivalency with the innovator. So that's why it's a very less expensive development program, but still it's a burden to prove sameness of NDAs. So there's we can summarize two kind of development program usually accomplished in the pharmaceutical R&D centers and whatever business is there. So second, being an insider, this is the typical R&D team structures. So where is one is drug substance and drug product. Those are the formulators. And here, if there is a bulk drug industry, then R&D center, then there are organic chemists. Usually this first drug substance, drug product teams, pharmacy graduates, chemistry graduates, mostly preferred. And second is analytical, where I belongs. And there are two categories in analytical, two non-clinical and another is bioanalytical. So in non-clinicals, it's a teamwork with drug substance and drug product. These are the two teams are very core team of R&D, and almost every industry, small to big developed industry, has those two teams. And rest of teams, clinical and all support teams can be outsourced, and some few developed majority developed companies has those two teams within their R&D. So clinical, these are the majority folks are pharmacy, pharmacokinetics, pharmacodynamics experts, and medical doctors. And it's a full-blown clinical study involved. And there are a bioanalytical section where chemistry graduates and pharmacy graduates may have a good career in that. And that belongs to biological. It's obvious bioanalytical means they have to do a lot of PK studies and handle to PK samples. So blood plasma, urines, and all those analysis involved. And there are support teams. So the most important is intellectual properties, because nowadays there are heavy duty litigation involved, and a lot of technology are patented and scientists doesn't understand, and they may unknowingly infringe the patent, and many companies bankrupted by litigations, and they have to pay heavy penalty. So in that way, intellectual properties roles is that whatever drug discovered by team, that has to be gone through by intellectual property. So they will give green flag, okay, no patent. We are not, this technology, whatever we are developing is safe. There is no patent involved and any litigation or something. And they will protect the company's intellectual property too by patenting the technology. So in future, company technology is safe. And another is regulatory affair. And definitely regulatory affair nowadays, regulations are so complex and tough, and it's very challenging. So that's a very hard and very critical teams. And another last one is project management. Project management means it's so complex. A lot of things company has to outsource and to just to coordinate with each other's teams, and not to diverse diversified focus on analytical and formulation scientists. So these project management guys handle all logistics. But there are some other teams like IT, HR, finance, but these are the core teams, and majority time intellectual property, regulatory affairs, and project management team companies prefer to have some kind of background working experience in drug product, analytical, or clinical, so they can effectively understand need of those teams, and it's a kind of teamwork. So this is the typical R&D teams what I saw, and it depends on company structures and muscles. There are many of things nowadays is a era of virtual companies too, so they outsource everything. And few companies maintain only formulation, rest of all they outsource. It depends on their business model, but it's a typical R&D structure in a typical developed companies. So that's how I thoughtfully think about, okay, so that's day-to-day life of any drug development group. And that's my area with pharmaceutical development. So if it is a drug development, then they may have a different workflow matrix, but 90% pharmaceutical companies have that kind. Pharmaceutical drug development have that workflow matrix. So surprisingly, there are 60% experiments related to performance, which is dissolution, disintegration, tiability, performance of the product. And 20% is related to purity and impurity. That's a very key because it's a expiration. A sponsor has obligation to be a stable formulation till expiration, and it has to be stable to 24 months, 36 months. So that's the degradation, assessment of degradation of purity. So, and 5% is identity, means full-blown solid state characterization of drugs for the sense. And 5% now in formulation, polymorphism and particle size is the big challenge for us. And those have a very critical attributes of solid state characterization. So this is the typical our drug development workflow matrix, we can say. So here I just pick dissolution because you know that for degradation and solid state characterization will be taken care of in very early stage of development. But this dissolution and release test is continuous research involved in and heavy duty investment involved in this. And that's the only area where product can make it or break it. So that is the reason I just choose this dissolution. And if we have a 10 scientists, then we assign 6 scientists to this dissolution related experiment and research in our typical industry setup. So dissolution is that just to closer the dissolution test condition to the physiology, to the better the chances of predicting the performance. So that's a very obvious. So now this sector is very evolved, but every country has their own pharmacopoeia. Yes, India has an Indian pharmacopoeia, US has a USP pharmacopoeia, Japan has a Japanese pharmacopoeia. Those pharmacopoeias have inbuilt performance of the dissolution methods in their pharmacopoeia. And this dissolution method will ensure that whatever day-to-day batch and product are consumed by their citizen is a effective and same as intended, whatever used. So dissolution medium, close pH 1.2, small intestine 6.8, large intestine 7.2, 37 degrees Celsius, means human body temperature, and that's how dissolution method design and propose in their compendial process, and it is mandatory to meet the specific specifications defined in their respective monograph. So this is the typical apparatus used by industries, apparatus 1 and 2. These are the compendial, and there are all other USP 3, 4, 5, 6, 7 already officially well accepted by the regulatory agencies, and this is the means it is a mandatory to meet them to just have a assurance of quality and performance of the product consistently. But this is the very primitive, but since regulatory doesn't have it's a practical limitation, something is better than nothing, but this is not the foolproof predictive dissolution method. So this Professor Dressman is a very well-known name in the industry. She is the pioneer of simulating gastrointestinal condition in the fed and fasted state condition. Basically, any pharmaceutical dosage challenged by two conditions. One is after taking food and without taking food. And so these are the two conditions, how every drug behave differently. So Dr. Resmans come up with the recipes of dissolution medium and some conditions which can predict better simulation than classical dissolution condition defined and already adopted by the pharmacopoeia. So she came up with because so far compendial methods only focusing on only pH, body temperature, and agitation speed, but those are not truly exhibit the performance in the body. So that's why she did a lot of studies, and she come up with those kind of recipes with sodium tartrate, lecithin, and pepsin, and this. So and she has because above and beyond then pH, and she come up with osmolarity, micellar formulation, pH, along with pH. So it's very well known already. So that's many companies are consulting her, and she is providing now dissolution medium to simulate the gastrointestinal and more predictive bio conditions, dissolution condition. So this is the simulation of another company, TNO, is because nowadays scientists are very keen to develop some dry lab GI conditions, and the TNO companies come up with this kind of gastrointestinal model. But I may not able to give justice to this technology. So pardon me, I would like to have this clip so that maybe give you better insight.
We use drugs to help our body get well. The intake of drugs starts in our early life. Drugs can act different within individuals or by the way they are consumed. How can we investigate the processes in the human gastrointestinal tract after the intake of a drug formulation with water or a meal? That was the central question at TNO and led to the creation of the in vitro dynamic gastrointestinal models. We called it TIM. TIM is a simulation of the complete digestive system through a combination of engineering, chemicals, enzymes, bacteria, and dedicated software. The TIM has been divided in two systems, TIM 1 and TIM 2. TIM allows us to gain insights in what, how, and when to extend nutrients, but also pharmaceutical compounds become available for absorption. Both models can be adjusted to simulate the GI system of an adult or child. Let's take a closer look on the TIM systems. TIM 1. Here we see the stomach and the small intestine divided in 3 parts. Left and right of the small intestine, we see the dialysis or filtrate systems removing compounds to mimic the real-life situation. At all stages, we are able to take samples to investigate their composition. When the formulation consumed with water or food enters the stomach, it is mixed with gastric acid, lipase, and pepsin. It is pushed forward and backward due to the simulated mixing movements of the stomach. After administration, the formulation stays in the stomach, disintegrates, and starts to release the pharmaceutical compound. The small intestine in the TIM-1 consists of 3 separate compartments: the duodenum, the jejunum, and the ileum. In the first part of the small intestine, the duodenum, bicarbonate is secreted to neutralize the pH value. Bile is secreted to emulsify fat. Pancreatic enzymes are secreted that digest fat, carbohydrates, and proteins. Subsequently, the solubilized and unsolubilized fractions of the drug will follow its transit together with the other matrices to the jejunum and ileum. Next to the jejunum and ileum, membrane units remove the dissolved pharmaceutical compound continuously. It is this unique membrane system of the TIM-1 that ensures the removal of the released and dissolved drug in jejunum and ileum. This fraction we call the bioaccessible fraction of the drug. This all ensures a dynamic environment just like that found in the human body. At the end of TIM-1, the non-digested and non-released components are collected for further analysis and can also be used as input from TIM-2. TIM-2. The TIM-2 represents the large intestine or the colon. This part of the intestine contains a high density of many bacterial species, the microbiota. These bacteria play a crucial role in the further digestion of the undigested materials from the small intestine. Here in TIM-2, we can measure the interaction of compounds in the microbiota. At all stages, samples can be taken to investigate their composition. We have shown you an active model of the human gastrointestinal tract within a laboratory setup. We can perform research on how, where, and when a drug becomes available for absorption in our body. This model can help you accelerate your research on the fate of your drug and formulation in the human GI tract, food and drug interactions, formulation selection for optimal bioavailability or bioequivalence, pediatric formulation development, troubleshooting in relation to available clinical data. At the TIM Company, we are proud that we can contribute to further research on how to improve our health and our lives.
Yeah, so our scientific communities are heavily working on, and we have a collaboration with the many universities to come up with some automation and some kind of simulation in chemistry lab, because clinical studies and means those are the trials are very expensive, and it's not ethical too, especially for toxic drugs and everything. But these are the, before that, I would like to say that, so what is the role of our role of analytical scientist in this process? So we have a heavy burden to, means it's a just, so come up with a biorelevant dissolution condition. That's very challenge for our pharmaceutical R&D program. So in that way, these are the in vivo plasma concentration, which we can derive from the animal model or few human volunteers PK studies. And this is the deconvolution. It's very well established, and just for conceptual purpose, I'm just presenting this, and I don't want to be overwhelmed with the statistical data. And this is the typical dissolution. So if this is the PK profile where time versus concentration in blood, and if you deconvolute in vivo profile, that's time versus percent absorbed using area under curve. And here, this is our typical dissolution, percent dissolution and time. So, this is the linear regression sheet. which give us indication that our dissolution method is able to predict bio, and we have a IV-IV correlationship. But this is the very ideal condition. In real world, it is very difficult to get that kind of linear relationship between in vitro and in vivo correlation. But we have some kind of close relationship. So that's how we can predict through the failure biodata. When we come up with new formulation, at that time we can predict how it will, we can forecast how it will be, how close it will be our targeted range of bioequivalence or PK study and whatever is our desired outcome. So these are the dissolution conditions and SEAM and team to the team this TNO, our studies, but still it's in a very primitive and debatable area, and FDA is not accepting right away, but it will very helpful. So thing is that the classical dissolution methods, which is already official in monographs, are very static and very poor predictability. It's good for quality control purpose because we have a practical limitation, but for research purpose, those methods are not too useful. So development capability of effective biopredictive dissolution condition is a very valuable asset for any R&D team, because accurate forecasting of in vivo outcome via the dissolution data minimize the clinical trials on humans and animals. The success rate of successful clinical bioequivalence study in first attempt is less than 20%. And the one clinical trial on about 25 humans or human volunteers, especially in India, cost about $200 to $1 million. And in US and Canada, it's more expensive. And turnaround time is about 2 to 6 months. So it's not, and other than ethical reason, it's a very heavy duty business consequences too. So an FDA is accepting and encouraging industries to conduct in vitro equivalencies in alternative clinical study, especially for toxic compounds. So that's a very emerging and evolving area where it's a lot of work needs to be done. And it's a combined effort expected from the engineers, pharmacists, and artificial intelligence. So one day we may be able to eliminate at all human studies. So that's the things really interesting me, and I hope so it may give some insight to that. Thank you very much. So I'm done. Thank you very much. Thanks for listening.
Thank you so much, sir, for your valuable speech.
Yeah.
Thank you, sir.
My pleasure. It's my honor to be here. And thank you for organizing this event.
Thank you so much, sir. And it was really informative. Thank you so much.
Thank you so much, sir. And the lecture was very informative. Actually, simulation, it's really work. We always imagine the GI tract biologically. Now you impart it in chemical chemistry way. That's really informative. Thank you so much, sir. Thank you. On Department of... and since we have a time lapse of 10 hours, and instead you join in the, since it's 6:30, I think they are in New York, right? Thank you so much. Thank you so much, sir. Thank you. As Dr. Shilpi ma'am has to leave, so Thank you, ma'am. Thank you so much for your coming, and you have come and take out of your busy schedule. Thank you so much, ma'am.
The roots of all goodness lie in the soil of appreciation. So it's time to present memento to our guest. I request respected Ruchi Srivastav ma'am, HOD of Chemistry Department, to kindly present a memento. Thank you, ma'am.
Thanks, everyone.
Here, we also have another guest connected to us through online mode, young rising talent, Ms. Maria Chaudhary ma'am from Western University, Canada. I request you, ma'am, kindly interact with our students and motivate them for recent research.
Hello everyone, can you hear me?
Yes, ma'am.
Okay. Hi everyone. Thank you for having me today. It is my pleasure to be here and share breakfast or I don't know, should I say lunch with people. Thank you, Dr. Sharma, for reaching out to me. I always see women researchers, which is amazing, and you guys have really amazing role models to look up to. So begin with, I can share my slide and give a quick review of what I'm doing. Just a second. So I am Riya Chaudhary from a PhD candidate at Western University in Canada. I have done my bachelor's from Calcutta University in India and my master's from Pondicherry University, after which I was working in an R&D, a contract research organization called TCG Life Sciences in India, which is based in West Bengal, before moving to Canada. So here, first, I would like to share some really cool pictures from last year where I had received awards, 2 travel awards for visiting Sweden at the International Roundtable Conference on Nucleosides, Nucleotides, and Nucleic Acids. And I was also selected as a spotlight for Chemical Institute of Canada for working on equity and diversity. To quickly introduce my research, I work in the field of bioorganic chemistry. I modify nucleobases and make them fluoresce, also give them environmental sensitive properties for nucleic acid-based probes. A little bit of background. As you all know that nucleic acids are known to store and transfer genetic information, but this is not what they are restricted to. Over the years, we have seen that nucleic acids are modified to be used as drug candidates. And then we have artificial nucleic acids, which are so often used these days. We have also heard about the RNA vaccines. I have shown the natural nucleobases, cytosine, thymine, uracil, adenine, and guanine. Now, unfortunately, these are not emissive, but we want to use natural intrinsically, we want to modify these nucleic acids so that they can be used for detection purposes as well. Now, since these nucleic acids are non-emissive, we want to make them emissive, and all previous modifications led to emission in the blue region of the visible spectrum. Now, it is very important to break the blue barrier because everything in our biological system fluoresces blue. So we need our probes to have red-shifted emissions. So for my research, for one of the first projects that I have done, I have taken inspiration from the green fluorescent protein chromophore, which is found in jellyfish. One of the interesting properties of this chromophore is that when it is bound in the tertiary beta barrel structure, its fluorescence emission is high. But when it is in unrestricted environment due to molecular rotor properties, it keeps rotating really fast and it loses its energy as non-radiative decay. So I have modified uracil and put the GFP chromophore modification and put them on artificial nucleic acid like the peptide nucleic acid backbone. So the idea here is that when it is present in a single strand, due to less restriction in its rotation, it will not fluoresce. But when it binds with its complementary strand, due to more restriction, now there will be fluorescence emission. Now, where is this kind of research helpful? Like we all know about RT-PCR, which is being used for coronavirus detection. So in that RT-PCR, they use a template strand which has a quencher and a fluorophore. So when it is not binding with the viral strand, the quencher quenches the fluorescence of the fluorophore. Once it gets the viral strand, it binds, forms duplex, and the quencher and the fluorophore are at greater distance, and they cannot the quencher cannot quench the fluorescence. So if I were to use my molecule in that same template strand, when it binds with the viral strand, we won't be needing a quencher and a fluorophore separately. My single molecule will be able to give fluorescence when it binds with the viral strand. So what did I achieve? I made a bunch of these molecules taking inspiration from various sources like the GFP chromophore or the dicyanovinyljuloledine type molecule. And I was able to make them environmentally sensitive. And also, as you can see, I have amazing green fluorescence and the very first ever, the yellow fluorescence for nucleobase. Now, these, due to the single bond and the double bond in the structure, they are more flexible to rotate in unhindered situations. So this is what a molecular rotor is. What did I achieve? I achieved bathochromic shift in emission wavelength, and like 600 region has never been done before. Then I have also got environmental sensitivity, that is in viscous solvents in like glycerol, there is a fluorescence increase, while in non-viscous solvent, due to unrestricted rotation, the fluorescence emission is really low. I have also received polarity sensitivity with my molecules, which is really good for detecting certain diseases and get to know more information about what is going on inside the cell and the nucleus. Now, the end goal is to put them in strands, whether it is peptide nucleic acid strands or DNA strands, and then bind them with complementary strands. And when I took one of those molecules, put them in a peptide nucleic acid strand, and did a binding study with complementary DNA strand, I had seen this amazing mismatch distinguish between the matched, like since it's a uracil, its complementary is adenine, and it has shown amazing stability as compared to the mismatched strand. So this can be very helpful when we're trying to find absence of nucleobases or some mutations in the DNA itself. Now, in other studies, what I have briefly done is I have made G-clamp molecules. So what is a G-clamp molecule? It is basically a modified cytosine analog that instead of forming the 3 hydrogen bonds with its complementary guanine, which we all know, it forms 4 or more hydrogen bonds with the guanine. Now, why is this important? Now, various diseases like Alzheimer's, certain other neurodegenerative diseases, and cancer are known to be formed due to the formation of G quadruplex formation. So in the chromosome, in the telomeres where it is guanine rich, they form very stable quadruplex structures, and these are responsible for certain mutations. So G quadruplex have been found to be a very important therapeutic target. And with our modification where it could form 4 hydrogen bonds with the guanine, it was seen to effectively disrupt this G quadruplex. So I want to quickly move on due to time constraints. And here I'm showing that apart from breaking blue barrier in research, I am also trying to reduce the gender gap. As you can see, that's on the right-hand side. It's me in TCG Life Sciences, where I was working as the single female in a group of like 21 male colleagues. And needless to say, on my first day, I did hear how women are not capable of taking on the workload of the client. But eventually things changed very quickly, and I was one junior chemist dealing directly with the client. And then again, here is on the left, top left is my group now, and I'm still the single woman, but it is very important to acknowledge the how effective diversity brings to a group. It brings creativity, it brings different angles, and also increases productivity, which is why now it is mandated that if there are less number of female faculty or students, then they have to recruit more. Even in companies, it's the same, that they are strategically recruiting more women now. Also, outreach activities are really, really important for you to be leaders of next generation, because with outreach activities, like all the social prejudice exists till date, even in the era of Netflix, where they show shows like Big Bang Theory, where they show that all the science is done by the men, and women or girls have to be geeky to be able to geeky and nerdy to be able to do science. Cool women do not do science, which is really, really wrong. And we are trying to encourage young girls to take interest in science by making them do experiments by themselves. And mentorship programs are very, very important to not only enrich you, but also take others along with you in the journey to reach to the top. Now, a few advice from me. It is very important to build tangible research experience if you want to pursue a PhD or even build a career of your own in the industry. Because I know that I have been recruited by my professor, my PhD supervisor, because I had experience in the industry with working with lots of different reactions and chemicals. So it is very important to either have that industrial experience or have a paper which is tangible, which is considered tangible. But don't worry if you do not have a paper yet. Any kind of experience to show that people can understand is okay to have. Also, it is important for you to know that you do not need to know everything. Like Dr. Kavita also mentioned that women only approach a job when they are 100% sure that they'll get in. So that shouldn't be the case. Because you can learn at your job. The only thing that you need is to be a fast learner. So take that leap. It is very, very important. Now, volunteer in different labs while you can. You can just shadow some of the other graduate students who are doing different type of work. That way you get to learn different techniques and also to see which field of research interests you. It is very important to do lab rotation kind of thing, which is still prevalent in India and also some of the top universities abroad. If you are to approach job sector, it's very important to have your CV or the LinkedIn up to date. Go to LinkedIn workshops if you have. It is very important to have everything updated. Now, what leadership is? Leadership quality is not only about self-development. it is also to help others shine under your supervision. So how that works, sometimes if you are one of the people standing in front of a recruiter with a bunch of other people, and what our instinct is to step up and make everything about ourselves. But that's not what recruiters look for. They look for that whether you're taking others in the conversation with you. That is very, very important. So make sure that you don't hog the limelight, but you act as a leader. That is what attracts all the recruiters. Have faith in yourself, even when you're going for a viva or whatever you're going for an interview. If someone asks about your research, you should remember that no one knows better about your research and what you have done. So have faith in yourself. Now, coming to grad school, I have realized that time management is one of the most important things you have to learn to be able to succeed. Now, being women, we also have different other struggles, looking after family, which we as females, we are really expected to do certain job that men aren't expected as much. So there's a lot of juggling that goes on. So learn how to manage your time well. Maintain a healthy work-life balance. It is very important to do that because you do not need to work in the lab until 10 p.m. It is important to work effectively and efficiently in the time that you have, and then use the rest of your time doing something you love with your family or maintaining your health and well-being. So these are a few tips that I want to give if you want to go to the work field after. I hope this helps. With that, I want to thank you. Sorry, I cannot hear you.
Thank you.
Thank you so much.
Thank you. On behalf of Department of Chemistry, ISR IPS Academy, I, Dr. Ruchi Srivastava, Head Department of Chemistry, want to thank you, acknowledge you for the wonderful lecture and especially the friendly advice that you have given to all our audience and especially the females at the end of your presentation. Thank you so much once again to take out your time from your busy schedule. Thank you, ma'am, once again.
Thank you so much for having me. I really appreciate what you're doing here, the Global Women's Breakfast, and we are doing the same in our university. I'm heading out like in 15 minutes to organize the ones in my university. So thank you so much for having me.
Thank you, ma'am. Thank you. And thank you once again to all of you present over here for patience listening. Yes, I know that the time exceeds, but what can I do? We have to join our international speakers, and it will be not possible for us to organize such event in the morning. So we have organized in the afternoon, and we have 4 speakers, but all 4 speakers were wonderful and they have their word in their own subjects. So thank you so much once again all the students, and from tomorrow their classes will begin at 10 a.m. sharp. And thank you for faculty members for joining us. Thank you, Joshi sir, for stay with us because we want such elder person with us. Thank you so much. And Javi sir and Nishan sir, thank you so much. And our faculty members, Dr. Pratibha Sharma ma'am, Dr. Rana Jadhav ma'am, Dr. Manju Taksak ma'am, and Megha ma'am, and Dr. Amit Singh Thakur sir for all support to organize this event. And I must thanks to e-learning department for organizing stream live event and join our international speakers with us. And of course thanks to our Deepak Bhaiya and Ashok Bhaiya for all management. Thank you so much, all of you. Thank you once again. And thank you, Dipali ma'am.